Hi, this is the first section in RabbitMQ course, but before we start with RabbitMQ product, we need to understand the concept of a queue. Let's take a look on queue definition. Queue is a collection of entities maintained in a sequence. Sequence can be modified in two ways: by adding entities at the beginning or at the end, and by removing entities from the beginning or from the end. In the real world, we can imagine queue as a lot of people standing in a line to purchase, for example, cinema tickets. Some of them have already purchased the ticket, so they left the queue. But for some of them, queue was too long, so they decided to leave it without making the purchase. Only one restriction is that a person standing in the middle of the queue cannot leave it. It would be silly in the real life, but luckily we don't have to worry about it in computer science. In computer science, queues allow to model asynchronous communication between components. Typical HTTP request is a best example of synchronous communication. So client sends a request, then it waits for response as long as service is processing it. This pattern is best for requests with really short execution time. So what if time to process our request is counted in minutes? For example, let's imagine you placed a request in your bank application to download all bank transactions from past 6 months. Time to fulfill such request can be counted in seconds as well in minutes. If your bank application would use a synchronous request, then application would be frozen and your experience with that application would be weak. To optimize such cases, communication between components should be realized as asynchronous calls. The idea of asynchronous requests takes place when the first response is returned right away, but response contains only information that service accepted or rejected the message for further processing. Optionally, response may contain a task identifier. The full response with expected data will be returned later as soon as the service has processed our request. In such scenario, your bank application won't freeze and allow you to calmly wait for results with all transactions from past 6 months. Okay, what about most important queue metrics? Let's do a case study of example with people standing in the line to purchase cinema tickets. Unfortunately, cinema has single ticket office only. People will naturally start lining up in the front of the ticket office, forming a queue. As you see, it's not an optimal situation. People have to wait too long to be served. So overall user's experience is not that good. What the cinema should do to improve user's experience? They can definitely do a lot, but most natural approach is to open more ticket offices. As you can see, queues are now smaller and waiting time counted for individual person is reduced as well. Here we met two most important queue metrics: size and age. Those two metrics combined together give us the full picture of the queue state. Size of the queue is not enough to monitor system state. In the same way, monitoring of the age is not enough. For instance, let's imagine a queue with 1 million of messages. Based on that information, should any action be taken? If the age of the oldest message is, for example, 5 seconds, then mainly no, because it means that average messages processing rate is 200,000 messages per second. On the other hand, should any action be taken when you see queue with 10 messages? If the age of the oldest message is, for example, 5 minutes, then definitely yes, because your system doesn't process messages fast enough from this queue. In other words, you should start opening more ticket offices or wake up the cashier. As you can see, only two information combined together give us a complete picture of the queue's behavior. Unfortunately, RabbitMQ doesn't support queue age by default, but we will back to this in later lectures. Let's continue our cinema use case and transform it into hypothetical financial system architecture with queues. In the financial sector, people buy and sell shares based on recommendations calculated by complex mathematical models. So, our people can be market rates. Market rates will be stored in queues. Ticket offices will be a computing cloud that implements a mathematical model to calculate recommendations. And finally, cinema will be clients interpreted as an external system used for making decisions about buying or selling stocks on the market. Clients expect recommendations no later than, for example, 5 seconds after our system